Hello everyone. As you know already that we have not finished the curriculum yet. We're still missing the last chapter, the finance unit, and we will not be able to finish the finance unit this year. But that's okay. Other classes are like us too. You teachers next year will be able to accommodate that. So don't worry about it too much. So for this week, I just want to talk about the basics of the finance unit, which is the interest. So there are three topics that I want to talk about today. So simple interest, compound interest, and the effective interest rate. So before talking about those, we need to know what interests are. Interest is the money paid regularly at a particular rate for the use of money lent. So, for example, if you are having a mortgage or if you have a loan on a car, then you need to pay the interest for borrowing those money from the bank. Okay, and the next one will be delaying the repayment of debts. So that could be if you didn't pay up your credit card before the due date. If that happens, then the part that you didn't pay will be charged at a very high interest rate. And last one for investment. Let's say if you deposit your money in the savings account in your bank, then the bank will pay your interest for saving the money in the bank. So that will be another place that you will see interest. The first topic we're going to talk about here is the simple interest. It's a quick and easy method of calculating the interest. And the formula is I equals to P times R times T. So PRT. Now, what does each of these represent? I, of course, represent the interest you're paying or the interest you're receiving for an investment. And P stands for principal, and R stands for the rate, the interest rate. And the last one, T, stands for time. We've talked about interest already, and principal is the money on which the interest is paid. So either if you're doing an investment or if you are borrowing a loan, the principal is the amount that you're borrowing or the amount that you are investing. Okay, so the initial amount that you're using. The rate here is the yearly rate or the annual rate, which will be a percentage. Okay, and time is in years. So this formula is how much interest you're going to receive at the end of a period. Now, if you are investing money, then you not only want to know how much interest you will receive at the end of a period, you might also want to know how much money in total you're going to receive, including the initial amount that you invested and the interest that you're receiving. So the final amount, A, is the final amount. Final of future. A is equal to P plus I. P is the principal and I is the interest. And we know I is equal to PRT, so it's equal to P plus PRT, which is the same as saying P P times 1 plus RT. Okay, so this one and this one have two formulas. All right, let's do a basic simple interest example. So the question is, how much money would you receive for an investment of $8,000 at simple interest for 5 years at 4% rate? So what do we know? What is the 8,000 here? 8,000 will be our principal. Okay, and we know it's 5 years, so T is equal to 5. And we also know that it's at a 4% simple interest. So the interest rate will be 4%. Now the question is asking how much money would you receive? How much money would you receive in the future? It will be the future amount. So the final amount that you're receiving, including the principal and the interest that you're receiving. So two ways to do it. Either you can use the A formula or you can use the I formula to find the interest first and then add that to the principal. So let's do both then. Let's find the interest first. Interest is equal to PRT, P times R times T. So that's 8,000 times R is 4%. Now, remember that whenever you're using percentage in a calculation, you need to change that to a decimal first. So that will be 0.04 times T is 5 years. So the interest you will be receiving is 1,600. And the future amount, the final amount, will be 8,000 plus the interest that you're earning, which is 9,600. Okay, so this is one way of doing it. Or you can use the A formula. A is equal to P times 1 plus RT. And so P is 8,000 times 1 plus R is 0.04 again, times T is 5 years. And if you do your calculation, it will be the same answer, 9,600. All right, the next topic we're going to talk about is the compound interest. Compound interest is the interest calculated on the principal plus any previously earned interest. So let me give you an example first, and then let's derive the formula together, or let's look at the derivations together. Okay, so my example is that the principal that I'm investing is $1,000, and the rate is at 1%. So for the first year, the amount I'm earning will be $1,000 plus $1,000 times 0.01. And because it's just 1 year, so I'm just gonna ignore the times 1 for the time. So this is the same as 1,000 plus 10, which is 1,010. So the amount I'm earning for the first year after 1 year is 1,010. Now, what is the amount that I'm gonna earn after the second year? What's the amount that I'm gonna receive after the second year? If this is calculated using the compound interest, then the principal is not 1,000 anymore. Remember that the compound interest is calculated on the principal plus any previously earned interest. So the principal, original principal, 1,000, plus the interest earned will be this one. So 1,010 will be our new principal, 1,010. And the interest is again one calculated based on 1,010. So 1,010 times 0.01. And again, times 1, I don't need to write that. So that's 1,010 plus 10.1, which is equal to 1,020.1. Now you guys can see a difference here. So for the first year, when your interest is based on the original principal, it's the interest you're going to earn is $10. On the second year, the calculation is based on the new principal, which is the amount received for the first year. Then the interest becomes 10.1, which is a bit more than the original interest. The reason is that it's calculated based on a greater value. So if you're calculating the amount you're going to earn on the third year, then the new principal is going to become this one. So you're going to do 1,020 0.1 plus 1020.1 times 0.01. And that interest will be even more than these two. As you move on, the interest you're going to earn is going to be greater and greater because the principal is become greater and greater. Okay? So that's compound interest. Now let's derive a formula for compound interest. If you guys look at this picture here, P stands for principal, R stands for rate, and time is ignored because it's always multiplied by 1. The gap is always 1 year. Okay? So on the first year, principal is the original principal. Interest is principal times rate times time, which is 1 year, so we ignore the T. So it's P times R. So the amount then, if you take out the common factor P, will become P times 1 plus R. Okay, so that's the amount we're getting for the first year. Now on the second year, principal is the amount that you're earning for the previous year. So on the second year, the principal is the previous amount. And interest is again principal times rate. And the new principal is this, rate is still R. So on the second year, your amount is going to become this. Does this become this? You guys can see that these two has a common factor of P times 1 plus R. If you take that out, then the first term become 1 and the second term has R left. So this is the common factor and this is 1 from here and R from here. Okay. Now P times 1 plus R times 1 plus R is P times 1 plus R squared. So on the third year, the principal is the amount from the previous year. So that's P times 1 plus R squared. And the interest, again, principal times R. So this is the amount that we're going to receive. And again, the common factor is 1 plus R, sorry, P times 1 plus R squared. So if we take that out, the first term is left with a 1, and the second term is left with an R. So this is our new amount. And if you simplify that, 1 plus R squared times 1 plus R is 1 plus R cubed. And keep going, you'll get to n years. You can tell that the exponent here is always the years. You see that? So for n years, our formula becomes this. P times 1 plus R to the power of n. So let me write that down. So your amount is equal to P times 1 plus R times to the power of n. But this formula is only for the interest, only for the compound interest that's compounded once per year. That means the interest is only paid once a year. But interest can be compounded more than once per year. So for example, you could have compounded semi-annually. It could be compounded quarterly, monthly, semi-monthly, weekly, bi-weekly, or daily. So this formula wouldn't work for those situations. Then our new formula becomes this. A equal to P times 1 plus R over N to the power of NT. A is the same, stands for amount. P is again principal. R is the rate, yearly rate. N is the number of times that the interest is compounded. If your interest is compounded yearly, then N is 1. If your interest is compounded daily, how many days are there in a year? So that's how many times you're gonna get paid. If your interest is compounded daily, then N is gonna become 365. What about compounded semi-annually? How many times are you going to get paid per year? 2 times, right? So for semi-annually, n is going to become 2. And t again is number of years. This is the formula for compound interest. Now let's talk about compound periods. So first of all, annually. If it's compounded annually, then how many times the interest will be paid per year? 1 time, right? So then n is equal to 1. If it's compounded semi-annually, then how many times? 2. What about quarterly? How many quarters are there in a year? 4, right? Monthly? 12 months in a year, so the interest will be paid 12 times a year. Semi-monthly? 24. Weekly? How many weeks are there in a year? You'll be 52. Bi-weekly? How many 2 weeks are there in a year? 26. These are the compound periods that are used most oftenly. And of course, there's also daily. How many days are there in a year? 365. Okay, let's do an example together. Okay, example. Suppose $8,000 is invested for 5 years at 4%. Part A. Find the amount of simple interest paid. If you guys still remember, the formula for simple interest is I equal to P times R times T. So it's gonna be 8,000 times 4%. 4% is 0.04 times 5. And this is equal to 1,600. Part 2. Find the amount of compound interest if compounded annually. So compounded annually, what does it mean? What does n equal to if compounded annually? It's 1. So your interest will be paid once a year. Okay. Now let's use the formula to calculate that. So A equal to P times 1 plus R over N times NT. P is 8,000, 1 plus R is 0.04, N is 1, 1 times T is 5 years. Okay, so if we calculate that, take a guess. Which one will give you a higher interest? Let's see. So if you calculate this, it's equal to 9,733.22. It seems like that this amount is super big. Is it the interest that you're earning? No. Remember that A stands for amount. It stands for the final amount, including the principal and the interest. If you just want to find the compound interest, not the amount, then you need to subtract this amount by the principal. So 9,733.22 minus 8,000, which is equal to. Now you see that? This is the interest you're getting for the simple interest. This is the interest you're getting for the compound interest. Of course, for the same interest rate, compound interest is gonna give you a lot more interest than simple interest. Okay, moving on to our last topic of this video, effective interest rate. It's the simple interest rate that is equivalent to what the compound interest rate will pay out over a given period of time. If you recall the example that we did previously, that given the same interest rate, simple interest will be different from compound interest. So this effective interest rate is to solve that problem. So we want to know what simple interest will equal to the amount that the compound interest will give. So why is this important? Why do we want to learn this? This is important because you can only compare various offers accurately if you know this effective interest rate. So let's say, for example, investment A is 10% interest compounded monthly, and investment B is 10.1% interest compounded semi-annually. Well, given these two investments, how do I know which one is a better offer? Which one should I invest? Looking at these two investments, we don't really know, right? So the best way to find out which one is a better offer is to calculate the effective interest rate. Okay, now let's take a look at how we can calculate that. Okay, formula. So the effective interest rate is calculated by comparing the simple interest and the compound interest. So right here, this is the simple interest and this is the compound interest. So after 1 year, T is 1 for both. Then the amount for simple interest is P times 1 plus R, and the amount for compound interest is P times 1 plus R over N to the power of N. Because E is the simple interest rate, so let's use E to substitute the R in the simple interest rate formula. So then we know that the simple interest will give the same thing, same amount as the compound interest. What we want is just to calculate the E here. So if we let the simple interest equal to the compound interest, then we'll be able to calculate E. P's on both sides, so P can be cancelled. That means 1 plus E is equal to this. So then E is equal to this minus 1, where E is the effective interest rate and N is the same as the N in the compound interest formula, so the number of periods per year. And R is the interest rate per year, which is also called the nominal interest. Okay, now we know the effective interest rate formula. Let's compare these two investments and see which one is a better offer. So investment A, let's write down the interest formula first. E is equal to 1 plus R over N to the power of N minus 1. So for investment A, E is equal to 1 plus 10%, so 0.1 over N. It's compounded monthly, so N is equal to 12 to the power of 12 minus 1, and that is equal to 0.1047. So this is 10.47%. Let's take a look at investment B. Plug into the formula. 1 plus 0.1 or 1 over, it's compounded semi-annually, so 2 times a year. And let's calculate that. It's equal to 0.1036. So this is 10.36%. 10.47 and 10.36. Which one is a better offer? The better offer will mean that the investment will give you a higher interest. So this one will be a better offer. That's it for the 3 topics. If you guys are interested, there are a lot more in your workbook. You can try the practice questions or you can take a look at the examples if you still don't understand. If you have questions, you can let me know. I'll be able to help you.